So guys, starting Unit 6 today, we're working with what we call systems of equations. Today, there's 3 methods for solving systems of equations, and today we are going to be solving using graphing. That's why our AO had graphing in it, okay? So 6.1, we are solving linear systems graphically. Okay, so we have a couple definitions for you before we start. The first definition is the definition of a system of linear equations. A system of linear equations is 2 or more linear equations that define a relationship between quantities. So there will be 2 or more equations put together, meaning we will have 2 or more variables. Okay, one more definition, guys. We're also going to define today the break-even point. The break-even point is the point on the graph where the cost and the income are equal, okay? So when we graph our system, the break-even point is the point when the cost and the income are equal. Example 1. I do want you to write the problem. Guys, it's only one. This is the only one. I'll underline the part that I want you to write, yeah? Yes. Okay, because I'm setting up the situation. So, we have, our main character today is Gwen, and Gwen has a part-time job working at Reliable Robots. We're shortening it to RR. Reliable Robots sells hardware parts for robot creators. Robot creators. Part of her job is to analyze RR's finances and determine the break-even point for the cost and income. Here's what I want you to write. RR purchases gears for $5.77 per gear plus a one-time shipping fee of $45. I want you to write that. I also want you to write that RR sells each gear for $8.50. So you only need to write those last 2 sentences, okay? So what we want to do here is we want to determine the break-even point for when the cost of purchasing the gears for RR intersects with the amount of money that they make. So we're going to be writing 2 equations. So what I want you guys to do before we start is leave a little bit of space so that we can write 2 equations and then draw your graph. So we're going to write an equation for the cost, and we're going to write an equation for their income. So let's first write one for the cost. Label it cost. And the cost means how much it costs the company to purchase the supplies for their product, okay? So which sentence, this first sentence or the last one, determines their cost, how much they spend? The first one. So let's read what it says. It says that they purchase gears for $5.77 per gear, plus a one-time shipping fee of $45. So we need to pick a variable first. What do you want to call the variable? G. G. Okay, so let's call it f of G. So the function of G. G is our variable. How much does each gear cost? $5.77. So how would we write that? 5.77 G. Excellent. But they also have to pay a shipping fee. So what would we do with the shipping fee? Add it to the end. So plus 45. I like doing like the equation again. Put it in there. That is an expensive shipping fee, but they're purchasing gears which are really heavy, and they're probably purchasing a lot at one time. So it's probably a deal. We'll see. So then let's write an equation for their income. So their income is how much they make based on what they sell the gears for. Which sentence, the first one or the second one, tells you how much they make? The second one, how much do they make? $8.50 per gear. So how would you write that as an equation? Or oops, F of G. Or actually, we need to pick a different letter than F, not F. What do we want to do? What? F of F? No, G is still our variable because we're still talking about gears, but we can't call the function F because this one is F. So H of G equals, how much do they make? 850 per gear, so that's going to be 850 G. Is there anything added or subtracted to that one? No. So let's graph these two and we'll figure out where the break-even point is. So looking at the first one, 5.77 G plus 45. What's your y-intercept, guys? Let me zoom in just a little bit. We just graphed equations like this in the AO. So which point would you graph first of the cost equation? 45. So put a point at 45. So at 45, these are going by 25. So my 45 is going to be somewhere right here, just below 50. And then my slope here is 5.77 G. So we're going to have to plug in a couple things to try and figure it out. 5.77, that's almost 6, and then it's over 1. So let's see, if I plug in, okay, so to graph the rest, let's make a T-chart off to the side. And we have X's and Y's. So we're going to be graphing this guy, X's and Y's. Now on our X-axis, we're going by 5, so I'm going to plug in the 5 just to see what we get. So if I plug in 5 for X here on my calculator, that's going to be 5.77 times 5 plus 45. So my Y is 73.85. And we're just going to estimate because this is a graph. So at 5, I was at 73.85. So here's 75. So let's go just below it right here. Okay. Now let's plug in 10 because that's my next X value. So when I plug in 10, that's 5.77 times 10 plus 45. So that's 102.7.
Do you have to add 45 again?
Yes, you have to add 45 every time because we're plugging in different numbers every time. So at 10, if I bought 10 gears, our cost would be 102.7. So here's 100, and then we're just above that. You still have to pay shipping on Amazon. Let's plug in 15. So if I bought 15 gears, it's going to cost us $131.55. So when we bought 15 gears, this is 125, so 131 would be somewhere right here, and it should start making a line, right? Let's do one more, and then we should be good. So when we buy 20 gears, that's 5.77 times 20 plus 45, 160.4. So when I buy 20 gears, I pay 160.40. So here's 175, so it's going to be somewhere right here. And they should start making a line. So what I want you guys to do now is let's draw the line going all the way to the end. Try and make it as straight as possible. So use the side of your binder or a piece of paper or something.
This is the best line ever drawn.
And what do we always put at the end of a line?
Arrow.
An arrow, because it goes on forever. And then let's label it cost. So we know that that's our cost line. So this line represents how much it would cost the company per gear that they buy, and then this is how much they spend. So when they buy 5 gears, they spend $73.85. When they buy 10 gears, they spend this much. When they buy 15 gears, they spend this much. When they buy 20, they spend this much, and so on. Does that make sense? When they buy 25 gears, how much do they spend? Exactly 200, right? So this is how many you buy, this is how much it costs them. Yes? Okay, so let's graph the income then. Their income is represented by 8.50. What is the y-intercept here? The y-intercept is always what's being added or subtracted to the end. So what's the y-intercept? 0, which should make sense because if they sell 0 gears, how much money do they make? Nothing. Okay. $0, yeah. Okay. So we're going to do a T-chart for the next one too. So just off to the side, X and Y. And we're going to basically do the same thing, but for the income now. So when we sell, so this time we're looking at when we sell 5 gears, we multiply that by 8.5, we make $42.50. Okay? So when we sell 5 gears, we make $42.50. So that's going to be somewhere, this is 25, so that's going to be somewhere here. When we sell 10 gears, how much do we make? 8.50 times 10, what's that give me? 85. We make $85. So when we sell 10 gears, we make 85. So here's 75 and 100. So 85 would be somewhere right here. When we sell 15 gears, I'm going to use the calculator again. So 8.5 times 15, we make $127.50. So when we sell 15, here is 125, so it's going to be like right above that. And let's do one more for 20. When we sell 20 gears, 8.5 times 20, we make $170. So 20 gives us 170, which is right here. So let's draw that line. And label it income, please. Okay, guys. So what is the break-even point? At how many gears do they make the same as they spent? 20. Or it looks like according to this graph it's about 20, right? So let's circle it for me and label it break-even point. Okay, now if you look at our T-charts, were they exactly the same? 160 and 170. Why do you think that is? Yeah, because there actually will be an exact point where they'll be selling and making exactly the same, but why do you think that maybe on our graph it looks like they're exactly the same, but when we plug everything in, it's not? Yeah, well, the graphing is not 100% accurate because with a graph there's always some error on where we could put our dot, right? Especially because we were getting values that were not exactly on the grid line. So our break-even point is about 20 for this problem, but with the graph, it's not, we can't rely on it totally 100%, but it's a good way to estimate. So I want you to write beneath your graph the break-even point. is about or is at about 20 years. Okay? So a graph just can give you an estimate, but this is going to be our first method of solving. So we had two equations, one for cost and one for income, and we graphed them. So we were graphing our income and we graphed our costs, and we determined where the two met. So where how much they were spending met how much they made in terms of dollars, and that's what we call the break-even point. After the break-even point, they just start making money. Does that make sense? Because at some point, you have to sell enough to where you start actually making money to offset your costs. So our graph is not always going to be 100% accurate, but it does give us a good idea as to where our break-even point is going to be. So what you guys are going to do this weekend on your homework, which I'm going to let you start now, is you are going to be graphing some situations and determining the break-even point. Okay?